Hello everyone, welcome to our Trust Structure Analysis project. Here we can add nodes and here we can connect nodes with elements, and also user can assign boundary conditions from there. For example, we can fix node 1 x direction like that and y direction like that. Magnitude 0 for displacement means fixing, and by clicking the clear structure button we can clear visual and also all information. By reading node list element list button we can also read different shapes. And if we click the run button, we can see the node list, element list, and extended node list of the structure. And in the results part, we can see results. In the first figure, you can see stress distribution, and in the second figure, you can see total displacement. And also, you can shift between x displacement, total displacement, and so on. And we can change the colors, and by the exaggerate bar you can simplify or exaggerate more. This is all for the part 1. Let's move on to the second one, which is bridge optimization. In bridge optimization part we can read file from Excel. So let's upload the one file and see the result. Yeah, this is the initial structure of our analysis. So you can see the total weight, density, area, and the elastic modulus. These boxes can be edited by user, and then we shift to the optimization phase. But first of all, we need to understand the logic behind our optimization. So let's move on to the logic. Let's understand the basic logic behind our bridge optimization part. Close parallels exist between arches and hanging chains. Adding external loads to lightweight chain shape chains considerably. Mirror image of hanging chain, we get an arch. Chains are tension systems that they automatically reshape to better carry whatever load is applied. Because arches are compression systems, they do the opposite. If they are not shaped appropriately for the loads that are asked to carry, they can collapse. In our project, this results unbalanced stress distribution, which increases maximum deflection. If they are shaped properly, they give the best results. So the question is, how can we figure out the shape for the arch? We just hang it upside down so that it works like a chain system. Then we apply the forces and turn it side up. In our code, very similar thing is used. First of all, force should be converted to equilibrium forces that hang from the arch of the bridge. If not, bridge rod will approach us to the arches, which is not desirable. After converting the forces, we can hang the bridge upside down. We can see the deformation and mirror it back. This makes one iteration. These pictures are exaggerated, so code makes hundreds of iterations in average to find the optimal bridge shape. This is the basic logic behind our optimization part. Now we can switch to our screen to optimization tab. Now we can see the initial file that we are uploaded, and we'll see some figures. We need to press optimize button, but first, if we need to fix rod horizontally, this switch should be on position, and if we need score based iterations, also this switch should be in on position. And if we click the optimize bridge button, see iterations done is increasing, maximum deflection is decreasing, and total weight is increasing and score is decreasing. When the score starts to increase, program stops and shows the optimized bridge. If any element reaches 3 meters, it gives warning and stops the program. And also, merge closed nodes button makes the adjustment that it merges two closed nodes and shows the updated version. In this figure, we don't have this. And if we click that button, we can see the adjusted bridge, and it is stress distribution. And also, for our logic, here is the small box and reference video and the calculations for the score. For the stress distribution and total displacement, we can also see better in these bigger figures. We can switch x displacement, y displacement, and see total displacement and also stress distribution. And also we can change the colors. So for the optimization part, That's all, and let's move to the mesh structure analysis. In the mesh structure analysis, user can select different structures to analyze. These are beam with no void, circle voided, square voided, and rhombus voided beam. User can also select operation that is wanted to apply. These are extension, expansion, and shear. User can also shift in between total displacement, x displacement, y displacement, and stress distribution. Let's try circle voided beam with shear. If we click that button, mesh appears, and if we click the shear and then click to the run button, we can see the analysis. Also, user can add additional boundary conditions from right top corner, from here, and for the clear button we can clear the structure. And lastly, also we can try beam with no void. If we click that, we can see the mesh, and if we select extension and run, we can see this stress distribution. And also, if we want to see the total displacement, select total displacement, beam with no void, extension, and select run. Here is the analysis, and thanks for watching.